In this lecture, we will talk about vectors. A vector is a quantity that has both magnitude and directions. And here in mathematics, if a vector has a big magnitude, normally we draw a length longer. If it has less magnitude, we draw a length shorter. So we use the length to denote the magnitude of a vector. Okay? Now, look at this one. Find the length of vector v. For vector, you want to write an arrow, okay, on the top. And here is not round brackets, is like arrow, a sharp bracket. Okay, that shows is a vector. If you know it's round bracket, that's a denote a point. Okay, so those two notations are different. This means a vector, -2, 9, with sharp brackets, and here round bracket shows is a point. Okay, now -2, 9 in xy coordinate plane, the first one is -2, the second one is 9. Okay, you can see here it's 3, 6, 9. Okay, 9 y coordinate, and x -2. So the direction from origin goes to this point is like this. Okay, so this is the vector for this one, geometrically. Now we know the direction now, and what is the magnitude? The magnitude will be the length. How to find out the length? You know, in this right triangle, this length is the length of the hypotenuse of this right triangle. So that would basically would be -2 squared, leg squared, plus another leg, then squared. Add together in our case is 4 plus 81, which is 85. Then choose the square root. That will be the length of this hypotenuse, and which is the magnitude of this vector. Okay, this is by Pythagorean theorem. So it's quite easy to find out the magnitude, and also when you draw the vector, you also know the directions, the direction of this magnitude. Okay, here again, for the vector, find out magnitude or how long and the direction. Those two things are very important. Okay, in this lecture, we will do this a lot. Another thing we want to do is addition, subtraction, and the vector times a constant. How are we going to handle those things? Before we go that far, we want to do is that there are some two special vectors. One is 1, 0, another is 0, 1. Those two are very special. Okay, you see 1, 0, x is 1, y is 0, so it's from origin to here. That's I. You want to put the arrow above it. And j, you want to put the arrow above it. And j is 0, 1, so it's right here. Okay, what is the length? The length is denoted like this. Yeah, 2 vertical lines on the left and 2 vertical lines on the right. That again will be x squared plus 0y. Here y is 0 squared. Choose the radical sign, and we know 0 squared is 0 plus 1 squared, so is 1. Choose the radical is 1. So this one has length 1. Yeah. And so is the case for j. You can see it down here. Okay, this line, the length of j is square root 0 squared plus 1 squared, and that's radical 1. Inside the radical sign, you have 1. Since the length of those two vectors, the lengths of those two vectors are 1. So I and j have a length 1. We call I and j are unit vectors. Okay? Means unit vector means length is 1. Alright, now let's keep going. This is example 1. Let's see example 2. Example 1 and 2. 1, 2. Let's see example 3. Example 3 is that find a unit vector that has the same direction as v, negative 2, 9. We know v previously is this v. Okay, that's no doubt. V is this v. Okay, the same v. Now we want to find a unit vector with the same direction. We know the length is radical 85. Okay, we know the length of this one is radical 85. Now we put this radical 85 as a denominator of, we use radical 85 to divide those two. We'll see what happens. We'll divide negative 2 by radical 85 and 9 divided by radical 85. My claim would be this will be the one we wanted. Unit vector. Why? Look. So how to find out the length of u? That will be square root of the first one squared plus y squared down here. Okay, and then you know negative 2 squared is positive 4. Radical 5 squared is just 85. 9 squared is 81. Radical 85 squared is 85. Numerators are both 85. You add denominators are both 85. You add numerators together, that's 85. 81 plus 4. 85 divided by 85 is 1. You choose radical 1 is still 1. So the unit vector is quite easy to find out. As long as you find out the length of this one and using length as denominators for x and y, then that vector will be the unit vector with the same direction as the given vector v. Okay, this is a very good technique for us to find out the unit vector with the same direction as the previous one. Okay. All right. Now, let's look at 4. 4 is that you want to find a vector that has the opposite direction of the given vector negative 2, 9. Again, here we use the same vector negative 2, 9. Okay. All right. We know in the xy coordinate plane, negative 2, 9 is this vector. Okay. Now, if we put negative sign to both numbers, let's say negative 2 comes to be, put a negative in front of it, and that's going to be negative, negative is going to be positive. And we also put a negative 9 in front of 9, negative sign in front of 9, so then we have this one. You see, this one is positive 2, negative 9. And when you sketch this vector, then you know this one is totally different, opposite to this one. Those two have the same length, but the direction is different. So to find out the opposite direction, you just need to put the negative sign in front of both x, y coordinates. Let's say that's v. Okay, so negative, you put a negative in front of negative 2, that's positive 2. and positive 9, you put a negative in front of it, will be the vector with the opposite direction. Okay? Great. Now, that's 4. Let's look at 5. 5 is find a vector that has the same direction as this one, but with the half length of u. Half length. We know this u is the u we had at the very beginning. Okay, you see? This is now we want to find a vector which is half of this of its length. We know originally is radical 85 is the length. Now we need to have a vector which is radical 85 whole thing divided by 2. Okay, so how are we going to find out that? Actually, it's quite easy. Is you use 2 to divide x and use 2 to divide y. That will be the vector we needed. Okay, we divided by positive 2 to both numerator and denominator, and this one will be the one we wanted. Look, let's find out the length of this one. You see, the length of this one is negative 1 squared plus 9 over 2 and then squared. Negative 1 squared is 1 plus 9 squared is 81, 2 squared is 4. Okay? And then we know 1 is 4 divided by 4. Okay? Plus 81 over 4. And 4 plus 81 is 85. Downstairs is 4, so we keep it. Okay? So 4 downstairs, upstairs is 85. Now, 85, you choose the square root, is still radical 85, and radical 4 is 2, and that's the half length. So V is the desired vector. Okay? Yeah, so find the vector that has the same direction as this one with the half length of u. You simply use 2 to divide both x and y. Okay? If you want to double the length, of course, then I think you know would be what? 2 times negative 2, 2 times 9. You will get a vector with the same direction, but the length is doubled. Okay? Yeah. So when you use positive number, they will have the same direction. But when you use negative number, then you see here, then you will have a direction is totally opposite.